2-5, solving proportions. And this is a very long lesson that we're actually going to split into 2 videos. And really in 7th grade, this lesson on solving proportions actually took up a whole chapter almost in 7th grade. So we're going to compress all of it into 2 lessons, which really in the textbook are only 1 lesson. So there's going to be a lot going on here. You can see from your Know It notes on page 26 that there's a lot of vocabulary that you need to write down. We'll write the examples down below that vocabulary on the bottom of 26 or on the bottom of 27. I'll definitely give you more examples than they have boxes for. So be prepared for that. I want to see all the examples in your Know It notes. So first thing, review of the term ratio. Right? A ratio is a comparison of 2 quantities. And you can write it with the colon in between, but writing it with the fraction is the most typical way. Okay, they don't always get reduced when they're ratios, but you can reduce them. When we have 2 ratios that are equal to each other, we call that a proportion. And there's an example there. 1 is to 12 as 2 is to 24. Right, so they end up just looking like a pair of equivalent fractions. If you need more time to write those down, right, go ahead and pause the video and keep writing. So our first basic example here, the ratio of the number of bones in a human's ear to the number of bones in the skull is 3 to 11. There are 22 bones in the skull, so how many bones are there in the ears? They've already written the ratio for us of ear bones to skull bones as 3 to 11. And right, if there are then 22 bones actually in the skull, right, we need to find out how many are really in the ear, right? So take 11, multiply it by 2 to get 22, and any time we multiply the bottom of a fraction, we also have to multiply the top by it, so we're really multiplying by a foo, a fancy form of 1 there. So we get 6 bones in the ear. Let's look at one more example here. The ratio of red marbles to green marbles is 6 to 5. There are 18 red marbles, so how many green marbles are there? And I think I actually probably would have written this the other way just because the information was given, right? 6 red to 5 green. It's a little confusing with the color of the pen, right? And it doesn't really make any difference though, because we just know we need to make, right, that be in proportion with, right, 18 red marbles. So it doesn't really matter if it's the 6 is on the bottom or on the top, as long as we're consistent. And so 6 times 3 is 18, so 5 times 3 is 15 green marbles. Okay. Don't forget word problem, word answer. I think we might have one more here. Nope, just kidding. Rates. Definition of a rate. Okay. A rate is a ratio of 2 quantities with different units, like 34 miles for 2 gallons of gas. Okay, so oftentimes we see it as things like miles per hour, feet per second, all those kind of things. Those are all rates. Okay? And when we write rates, we actually usually give them as unit rates because then we can actually compare them with other things. A unit rate is a rate where the second quantity, the denominator of the fraction, has a quantity of 1 unit. So that we're looking at 17 miles per 1 gallon, or it costs $3 per 1 pound. I can travel 55 miles in 1 hour. Okay. And you can, of course, convert any rate to a unit rate. You just have to divide the denominator of the fraction by itself and then divide the numerator by the same thing, and you will get how much per 1 unit. Let's take a look at an example. Remember, you can pause it if you need to finish writing down the definitions on page 26 of your Know It notes. Ralph Lau of Germany flipped a pancake 416 times in 120 seconds to set the world record. That's a lot of pancake flips. Find the unit rate. Round your answer to the nearest hundredth. So we want to know how many times he flipped the pancake per 1 second, right? What we already know is that he flipped it 416 times in 120 seconds. Okay? Now it gives me a little hint that I might want to use a calculator here because it tells me to round my answer to the nearest hundredth. So let's go ahead and pull up our calculator on the screen here. And we'll drag it out of the middle so you can still see the problem. And we're going to do, since we have to divide by 120 here on the bottom, we're going to divide by 120 on the top also. So 416 divided by 120 is 3.46 repeating. So we're going to round that up to 3.47 flips, right, per second, okay, per 1 second. And that's his unit rate, almost 3.5 flips per second. I don't know how you do that. Let's do one more unit rate problem here. Corey earns $52.50 in 7 hours. And if we want to know the unit rate, that means we want to know, right, how much he earns in 1 hour instead. So we're going to divide both the top and the bottom of the ratio by 7. Let's use our calculator again. It should be somewhere around 7, just estimating. 52 divided by 7 equals 7.5. So he's going to make $7.50 per hour, unit rate. I don't think we're going to need the calculator anymore. And all those examples, we've done 4 examples so far. I didn't tell you where to write them down specifically. They should be somewhere there on the bottom of page 26 or on the bottom of page 27. Okay. If you did not write them down, rewind, go back, and write all 4 examples down. And I think let's continue with this part. I'm not going to actually have this be part 2 quite yet. We're going to start part 2 in a little bit on a separate video. This we're going to make part of this video. Let's solve some proportions. You guys did lots of this last year, so you'd be very, very good at it, right? When we solve proportions, if we know 3 out of the 4 things, right, A, B, C, or D, any 3 of those 4, right, we can solve for the 4th one, right? And when we solve proportions, we use those cross products, right? Some teachers call it the super X, right, because it's this big giant X, right? And there is a spot in your vocabulary section for cross products, right? That's what you get when you multiply across the diagonal. Okay, multiply across the diagonal in a proportion. That's probably a good definition for it. Let's do a few basic ones. Writing this down somewhere on page 26 or 27. We're going to multiply across the diagonal. This should feel very familiar. 3 times m equals 9 times 5. Normally I just do that part in my head, right? So I would just really start normally with 3 times m equals 45. Divide both sides by 3. It's a one-step multiplication equation. So m equals 15. Okay, which I probably could have figured out if I'd reduced 3/9 to 1/3 and then just made an equivalent fraction. That would be another way to do it. We're going to do one more example here, this one of a more complex proportion, and we will definitely talk more about these ones in class because this is the new information in this lesson that you definitely need to know how to do. So we're still going to do the same thing. 6 times 7 is 42. And then here's where it gets a little bit different. We have 2 times the quantity y minus 3. And since I have 2 groups of y minus 3, I'm going to have to distribute. So I get 2y minus 6 equal to 42. and then I can add 6 to both sides, and I get 2y is equal 48, and therefore y equals 24. Okay, so same basic idea, except anytime there's an expression within the proportion, you're going to need to distribute to get it to be the right final answer. One last one. Writing it down still, so you should have a lot of examples on your paper. Okay. Distribute when we multiply. Right, so we get 4 times the quantity g plus 3 equals 35. And distribute, that's 4g's plus 12 equal 35. Subtract 12 from each side, and you get 4g's equal 23. Is that right? 35. All right, looks right. Okay, so g equals 23 over 4. That doesn't seem very nice. So let's just double check that. 23 over 4 plus 3 be 35 fourths. I'm just checking my work here. 3 wholes is 9 over 3. Okay. Oh no, it was over 4. Ah, Mrs. Bazovoy, you're confusing us. All right. Okay, I'm backing up here. Let's start all over with the check. So I have g is 23 fourths plus 3, which is 12 fourths, all over 5. So that's 35 fourths, okay, divided by 5. And if I'm going to divide it by 5, I could write it like this, right, instead. And I'm going to multiply, right, by 1/5 to multiply the fractions, okay, and cancel. And sure enough, I get 7 fourths, which is what's on the other side. So I am right. It's just an awful fraction answer of 23 over 4. Go figure. That is it for the first half of 2-5, solving proportions. We'll pick up with the missing stuff in the next lesson for tomorrow, or you can continue watching now.